Greetings, this is Artie from Artifact Electronics. In today's episode we'll be trying to revive this oscilloscope. It's been sitting in my pile of need-to-be repaired instruments for a while, and its turn has arrived. This is actually a Fluke PM3370B with a bandwidth of 60 MHz and a dual trace. And it's a so-called combi scope, and I think that name came from its originator because this is actually a Philips scope rebadged for Fluke. But what the combi scope means is that it's both an analog and a digital scope, and you can switch back and forth simply by pressing the big yellow button. Both the service manual and user manuals are available online. For this, the user manual is dated November 1998. It's pretty light at 20 pounds. And I remember when buying this, it looked like this, but it was several shades darker because there was a lot of accumulated dirt on it. And I can already tell you at least one person attempted to repair this and obviously failed. But anyway, I cleaned it up a bit. You may call me an optimist. Why am I cleaning this up if I don't know whether it's fixable? And that's because I prefer to work on instruments that are somewhat clean. It just disturbs me a lot when they're really filthy, as this was. And of course, the filthier an instrument is, the cheaper I usually get it, even though in the case of this one, I should have probably gotten it for free, or they should have paid me, because it was pretty nasty. But it was still very cheap, and let's see what needs to be done. When you turn it on, and I won't do this now because I don't like to turn things on that I know are defective and have a whiny power supply. But when you turn it on, the supply started to whine, not very loud, but you could hear it. The fan started to run at full speed. You could hear relays chattering, and that was it. The screen didn't light up, nothing came up on the screen, and even the backlighting, turning all of these buttons would not make anything appear on the screen. So let's open it up and see if we can see anything obvious in there, and also start diving into the schematics. So here's the top of the instrument with the cover taken off, and you can quickly see why this instrument is relatively light. And that's because the case is made mostly of plastic, and let's see, other than that, quickly going through the components, is we have the acquisition board here, the CPU board here, underneath it is the motherboard, the power supply, which generates all the voltages, including the high voltage, directly on here. We have the tube and the neck board. We have the video or the screen driver board over here. And here's the fan, and here's the light bulb that is used for Graticule illumination. And since the screen isn't coming up at all, there's no crackly noises or anything like that, my first suspicion is somewhere in the high voltage area. So let's have a look at that and see what could possibly be the problem. So here's part of the power supply schematic. This is the HV section, or the tube section in general. We have an oscillator over here going to the primary of this transformer, and from the secondary we get the neck board voltages. We get the cathode voltage over here, and 5 kilovolts that goes to the voltage tripler and generates 15 kilovolts. I hope that the voltage tripler isn't at fault, because those are usually very difficult to find replacements for. There are some nickel and dime parts. There's the rectifying diode for the cathode voltage, and two smoothing capacitors, and an inductor here, and there is a capacitor going to the HV tripler. So let's hope for the best and check those. So I pulled out the power supply board. These boards, when sitting plugged into the motherboard, are pretty close together, making it virtually impossible to work on them while the instrument is live or while they're in place. I guess you'll need some sort of an extender board, which I don't have. So I went ahead and did some component checking, and I hit pay dirt. This diode was open. This cap was open. Everything else was okay, but with the diode being open, the tube wasn't getting a cathode voltage, and that would be enough of a reason for it not to light up. So here's what the power supply looks like pulled out of the cage, and the affected components, which I replaced, are in this area over here. And let's see if I can get a better look at that. Yes, there you go. So this is the cathode voltage rectifier that I replaced. These two are the smoothing capacitors that surround the inductor for the cathode voltage. I replaced both of them for good measure, and while I was at it, I also replaced the high voltage capacitor over here. And let's have a look. I think at this point I feel confident that I can probably power it up without anything blowing up. Okay, here goes nothing. Oh. Okay. Well, the screen is live, and it does have a bit of a rotation problem, so there's a trace rotation control here. It beeps at me, doesn't do anything, and tells me something. Let's see if I can focus it at least. Oh, the message went away. Well, it looks like I'm able to focus. It keeps giving me that message, even though the trace intensity seems to work. The text intensity works. The focus works. The Graticule doesn't work. No acknowledge on I2C. Okay, I think what it's telling us, this is a Philips instrument, so it's probably using I2C all over the place for inner board and inner IC communication. So somewhere in here there's an I2C chip that is not responding. But the screen's on. So I'm going to let it sit for a while and see if anything bad happens. So here we are, a little while later. Did something bad happen? Yes, but we'll get to that in a minute. What I did forget to mention in the beginning, and some of you may have been tearing out your hair going, check the power supply. I actually did. I didn't put it on on video, but what I did, remember it's kind of difficult to get inside, but I just used mini clips and clipped them on to the respective voltages. There's about 8 voltages coming out of the power supply. Plugged the supply board back in and turned on the instrument and made sure that all of the voltages generated, other than the high voltages, on the power supply were good. I checked the ripple on them. It was within spec. So the low voltage on the power supply was all good. And after that I proceeded to fix the HV side. And now you're all burning to hear what the bad thing was. Well, I let it run for a while, and I was in the room cleaning up a little bit and looking for stuff and hoping I'd find my HV probe, when I heard a really loud crack coming from the instrument. I ran back. The instrument had turned itself off. There was no magic smoke. There was no bad smells, nothing. It just turned itself off. So what I did, even though this may not have been the wisest thing to do, but I didn't know what else to check, I rechecked the components that I had replaced, and they were all still good. So I turned on the unit again, and approximately 30 seconds after it was on, I heard the loud crack again. This time, the instrument didn't turn off, but the screen disappeared. So what that tells me is we have to go on a corona hunt. Now, what is a corona hunt? It doesn't mean that you're going to the convenience store at 4 a.m. in the morning to buy beer, but rather something is discharging, most likely the HV wire, which runs here and enters the CRT. Somehow it is discharging. And the best way to do a corona hunt is, and follow this closely, wear protective glasses, keep your face a respectful distance from the top of the instrument, and turn off the room lights, and then turn on the instrument. And that's exactly what I did. And here's what I found. So I went corona hunting. My face is still in one piece, so are my eyes, but I think I found something. And basically staring at it, I saw a large corona emanate from right over here, which is where the HV connects to the CRT. And what I found in there was, well, let me show you. So feast your eyes on this. Now remember from the previous scene that the high voltage went in on the side of the CRT, which made it really difficult to get to. So after trying out a bunch of different things, it was impossible to get to that connection. So I removed the tube and turned it 90 degrees. And this is what greeted me. This is exactly what it looked like. And so whoever worked on this before me had a hard time, had removed this connector, the HV, and then when they tried to put it back again, because there was so little space between the side and this, they just kind of squeezed it in there and couldn't figure out a way to get the insulating cup to properly slide under the shield, so they just left it like that. Corona was coming out right from here. I mean, I could see it. It came out from here and went to the shield. So I think that's why we were having sudden discharges, and those will wreak havoc on other parts of the circuitry too. So let me fix this, put the tube back, and see if anything has changed, or if everything still works. Now, remember, when working on that, be very careful, and don't forget to discharge the HV, what I use is, I have this thing that's called a circuit tester. It looks like a screwdriver with a really sharp tip, and the tail of it has this thick wire and this clip. And what you use it for is you clip the clip goes to ground, and the tip goes to either the neutral or the hot side of your AC outlet. And in the middle of this is a neon light, and if it lights up, then you know you got a live leg of the AC. What I did was I repurposed this. I removed the neon and basically put in a 1 meg resistor. Now, some people will put in much smaller resistors, but I usually put in, for discharging CRTs, I put in a larger resistor, so every time I discharge it, it doesn't scare the shit out of me. This one still cracks pretty good with a 1 meg, but it does the job with one contact. Even though you should not assume that when you hear a crack, that after a single contact you've discharged the tube. Repeat, pull it out and put it back in under here at least 3 or 4 times, and then you can be pretty sure that the CRT has been discharged. So for the sake of completeness, this is what I believe the insulating cup looks like when it is properly inserted with both of the clamps grabbing the CRT, but being underneath the shield and being stuck to the CRT. And this should prevent any further coronas or discharges from happening. While I was at it, here is, I had to pull this out, here is the Graticule illumination assembly, and it's basically uses light piping to light up the CRT with a incandescent 22 volt bulb. I pulled the bulb that was in here out and measured it, and it was blown, so I put in a new bulb, and let's put the CRT back and see if it lights up and if everything or anything still works. All right, I was able to put the puzzle back together again, and let's have another look here. Everything looks to be plugged in, and here we go again. Oh. So it's still not acknowledging anything on I2C, and all right. I'll let it run for a while, see if it's still going to arc. That's still kind of weird because the intensity can be changed, but it's telling me that it's not getting an acknowledge. So, well, maybe that'll give us some hints on what to look for next. But I'll let this guy run for a while and see if everything is clear. So I spent some more time studying the schematics and especially following the I2C paths, and what I ended up with was this, and it's kind of interesting because it's right underneath the HV supply where I fixed the rectifier and some caps, and it also physically is right underneath the voltage tripler, nicely obscured physically so you can't get to it while the power supply board is plugged in. But let's see what this tells us. So we have a quad DAC driven by I2C. We have the clock and data lines coming in, and it is a Philips part, a TDA 8442. Now that generates 4 analog voltages here. The top 2 are run through this and generate the trace rotation voltage, which obviously doesn't work very well. You may remember when I first turned it on, the trace was kind of straight, but then started to rotate as the power supply came up. So something is definitely wrong in here. Then one channel is used to generate the fan speed. Now, I don't really know if the fan's supposed to vary, but I let the unit sit here for quite a while I was doing corona hunting, and the fan never changed speed, so this most likely doesn't work either. And then last but not least, the last DAC channel is used for the Graticule illumination. And even though I replaced the bulb, and the bulb actually came on, but I could not change its intensity. And I kept getting that message that says I2C no response or whatever it said. So obviously the most common part is the DAC itself. And so I went out hunting for a replacement part, and of course this part is no longer in production. And but I did find two of them for sale on eBay US for not too expensive, and went ahead and ordered those. So as I mentioned, the DAC sat right here, right underneath the HV. This is the bottom, this is the motherboard connector. So you can imagine when this is plugged into the motherboard, it's kind of difficult to probe this. I did use grabbers again to at least make sure that the supply voltage was good on it, and I also looked for activity on the clock and data lines from the I2C, and they were there. But that doesn't really mean a whole lot because the whole system has a single clock and data line. But other things were working. It wasn't complaining about no response. But specifically the things we just looked at in the schematic were the ones that it was complaining about, and they're all coming from here. So I desoldered the old part and put a socket in, which I always do with parts that break, because they're obviously getting stressed somehow. And here's a replacement part. So I'm going to plug this in, and then we'll start up and see if anything at all changed in the operation. Alright, let's see if our new DAC is our friend. Well, let's see. And we have liftoff. Well, at least on the trace rotation. It works, and no complaint message. The light bulb isn't on. You should see it shining through the top here, but it's gone. It's completely gone. Well, we are one step closer, but let's go back to the schematics and see why that light doesn't want to come on. Alright, so the next question is, what is common to the fan and the Graticule illumination? And that's this part of the circuit again. And if we look at it, of course, other than the DAC, which now is working correctly, as can be seen by us being able to adjust the trace rotation, is they both have op-amps in their path. And it just so turns out that these are dual op-amps, and this is the same part. So that's common to the two non-working things. So I guess it's time to go ahead and replace those. I did test the transistors in circuit, and they look good. I got the same values, pretty much the same values as the other transistors, so now it was time for me to find the op-amp. And as I complained before, it's kind of a pain to work on this board because when you insert it back in and push it into the motherboard, there's a pair of locking tabs in there, plastic tabs, that lock the board tightly into place, which is very nice for operation. But every time I want to pull out the board, I got to go in there and finagle those two tabs so they let go of the board, while being afraid that I'm going to break the tabs because they're made of plastic. So it's generally not a very enjoyable exercise, but maybe we're finally getting to the end of this, at least with the power supply board. As I said, it took me a while to find the chip, but fortunately they do give you the board, the parts location board too. And after learning how to read the designators, I knew that this designator, which started with a VL10, meant that it was on the surface mount side of the board. And here's the culprit. I had a replacement op-amp. It didn't take very long to take the old one out and put the new one in. And so it's time to slide the board back in again and see if we're finally getting somewhere. All right, let's see if the op-amp replacement fixed the remaining problems. Well, the fan slowed down. And in order to test the backlighting, let me turn off the lights. And there you go. The Graticule illumination is working, and the fan speed seems to be working. So looks like we're in good shape. So here's the scope. It's reassembled again, and now let's make sure that it can actually display inputs properly. For that, I hooked up the signal generator to both inputs, and both traces are at ground now. I'm going to switch this one to AC and the second one to AC, and you get a nice clean display. This is analog mode, of course, and you can change amplitude on both channels, and of course the time base. So all of that seems to work. We can switch to digital, and can immediately tell it's in digital because of the way the waveform is being digitized. But so that seems to work too. And looking at some other waveforms, we have a sine, going back to analog, and square, which seems to need a little bit of compensation in both modes, but it looks like the scope is working. So it's time to do a wrap-up here. And what I'm going to do is have the instrument calibrate itself. That's usually a pretty deep test to see if a lot of the subsystems are working. Now I pressed the cal button, and it keeps saying instrument still warming up, but feels like it is warmed up. So let's see what gives. So that's going to take a little bit, and some final words on this. One thing that needs to be done that I didn't do yet, there's probably about 15 or 20 electrolytic capacitors on the power supply. Even though they all look good and measure good, it's the cumulative error that will get you in the end. So my next task for this shall be to do a full recapping of the power supply. And to sum up, what we did is we replaced a bunch of parts. One was the rectifying diode for the cathode voltage. We replaced 3 capacitors also in the high voltage area. Then we found that the quad DAC was bad. Subsequently replaced that. Then the opamp was bad. That was generating the proper voltages for both the fan speed and the Graticule illumination. So this got replaced. You'll see, I don't know if you can see that, but I had to cut the leads off it because it was glued to the board. You see those 2 light dots on the bottom of it. And there was no way of getting that out without cutting the legs and then prying it off the board. I didn't want to damage any pads, so that was the best solution for that. And finally, the light bulb, which is an incandescent bulb rated at 22 volts. The original was burnt, but those bulbs are still available, and that got replaced. If I turn up, oh, I guess I'm not supposed to turn any of these things while it's calibrating, so we'll find out if I messed up the calibration cycle here. But things seem to be running well. It's a neat scope, especially since it's dual mode, and I'm glad it got fixed. And I do hope that this will help you out if you ever fix a similar scope, or if you follow the general principles used in troubleshooting this and repairing this, and that should help you out on most any other scope too. The interesting part was that the problems were not only analog, but there was also logic problems with the DACs in here, which is fitting because it is a dual mode scope. So I hope you liked this, and if you did, don't be shy about clicking the thumbs up, and to make sure that you don't miss any of our future exciting episodes, make sure to calibrate. Make sure to calibrate. That was a Freudian slip. Make sure to subscribe. As I was staring at the screen, it did calibrate, so I think everything's okay. And the next few weeks, when I use it on the bench, will show. See you later.